Well, it's time to start. Well, I'd like to welcome everybody out this evening, afternoon or evening. My name is Lance Olson. I run the program management team for Cortana Intelligence, and I'm very excited to be here to talk to you today about the Cortana Intelligence Suite. This suite has a lot to it. It's actually quite extensive, so we'll spend this time really focusing on what the suite is, what's in it, how you can use the services to improve your applications. And we will do a number of demos where we'll dive in and we'll look at code for how to connect the pieces, although we won't have enough time to do really deep dives on each of the pieces. So think of this as an orienting discussion around what the pieces are, where to use them, and then some demos on how you can apply them into your applications. I have to say, working on pulling all the content together for this session has been an interesting experience for me because it kind of felt like describing a science fiction experience. The kinds of things we're looking at seemed really futuristic, and then I had to keep stepping back and going, but the APIs for everything we're going to talk about today are actually already available launching this week. So it will sound a little bit kind of out there, and then we'll talk about all the APIs you can call to do the things that we're talking about. Before we do that, I actually want to go back in time 20 years and kind of talk about the process that got us to where we are today. So who here was writing code 20 years ago? Okay, so do you remember these days? Does that look familiar to anybody? The good old days of the two-tier application, right? Forms over data. Doesn't it just take you back to wonderful times? So yeah, 20 years ago we had basically that was the primary architecture we had was two-tier. Then we introduced, and the web came along, and we moved into a model where we had web pages and apps coming out of the database, and we had a web server in between. And remember those pages where every time you clicked on the page, the entire page would reload? Remember those applications? But you can see the architecture got a little bit more complex. And then we got Ajax, and we started to introduce web services. And so then we moved into more of a three-tier architecture where we had the database, we had business logic in the middle, we could serve up different form factors. And then as mobile apps showed up and as the web apps got more mature, we started to get more complex. We started to get multiples of databases and multiples of services talking to multiple client front ends. And as we did this, we started to have a greater need to really separate out the different tiers, to separate the business logic from the presentation tier, from the data tier. Now, if we look at where we are even as recent as last year, we have a multiplicity of systems running here. We have multiple services pulling in different information for the applications. We have different types of systems running, pulling in. Some of them are web services, some of them are big data processing large amounts of data or unstructured or semi-structured data. You have multiple systems of record you might be accessing. You have unstructured data that you're pulling in into many services, and then you're serving that out to many different application layers. Now, this has actually gotten quite complex. And now I want to just walk through a scenario of I was in China 2 weeks ago and meeting with a major retailer in China, walking through the architecture for their application. And I wanted to walk you through the architecture that we talked about in that discussion and really what that looked like. So to start out, they had a web application and a mobile application. And think of this as like a retail company. And for their web app, or their mobile app, they also had the ability to log in through a social channel. So they said, well, if you want to log in through your social ID, then you'll have a common login. Of course, if they got that, then they'd also see the usage coming through, or they'd be able to connect and learn more about the user based on their social data. They also had people able to go online and transact using various transaction systems like mobile payments, and so they could learn from them there. And what they wanted to do is really take all of those views of the user and bring them together to have a common ID, a common understanding of the user that they were interacting with. Basically, the idea being the more that you can understand the user, the better of a job you can do in terms of making compelling application experiences for them. So they would feed all of this data into what they called a customer data hub, a central location where they had a warehouse with all of the data they could collect on the user. They would generate models, use machine learning to try and predict the behaviors of the user and feed those back into the application. They would tag the models and apply metadata that they could use to further their understanding about the customer. But then they also said, well, we have a bunch of other inputs that matter to us here. So we have this category we call offline activity, which is more like a point of sale. So if somebody actually comes into the store and pays, they have an identity system there and a payment. Maybe that's mobile pay, or maybe it's not. Maybe it's a credit card. And we want to correlate that with the other understanding we have of the customer. And then also maybe the person calls in either to a call center, like if they need help, or maybe they call in to do orders. And so there's a point of, there are multiple points of sale and multiple customer channels that we also want to understand. All of this is just one common view of the customer is what they're trying to get to. But it paints a very rich picture of the customer. They then wanted to take that information and the transaction information, feed that back into the customer data hub. So now I can look at the customer, my knowledge of my users from a social perspective, from how they interact with my site and the applications that I have, and from how they've also interacted with the products. When they come into the store, what do they buy? Or when they go online, what do they buy? All so that I can better understand that customer. Then I take that information and I want to feed it into various other optimization engines, like I might be doing search optimization based on what I've learned about the customer. If I know they search for these topics, these keywords, now I can actually better serve them because I understand what they want. I also might use that information to decide how I want to approach the customer. Do I want to do online ads? Do I want to do television? What other mediums do I want to use to reach that customer? So that actually drives that data back into my digital campaign, and that actually makes its way back into my applications. So now I might use that information to decide, I think this customer is ready to buy another widget next week. I'm going to give them an offer on that kind of a widget based on what I know about their history. Now I want to actually add other kinds of data. So I might want to look at, weather is a standard one. Do people buy more or less when it's rainy or it's hot or whatever the weather might be? I might want to understand other external factors like the currency, or in this case even they were interested in understanding the air quality. Do people, if it's food, or do people go out and shop more if the air quality is bad? So all these external inputs that become also critical to help understand the behavior of the customer. Finally, they then wanted to do things like, how do I reach the customer in the most natural way? I want to have different interfaces I want to be able to reach the customer in whatever interface is most natural for that customer. So it might be text interface or speech. I want to understand when the customer is happy or sad, and I want the application to actually behave accordingly depending on whether or not the customer is having a good experience with the app. And then finally, I want to generate analytics from the application that drive my business decision making. So I want to have a customer dashboard that lets me see all of what's going on, various slices, do exploration on that, and formulate new hypotheses about how I can better drive my business through my applications. So this is really a far more complex system than we had 20 years ago or even 5 years ago. And it really, what's changed here is that the applications, partly because there's so many different form factors, but also partly because you really need, in order to have a relevant experience, a compelling experience for the user, we actually need to have an intelligent system behind the applications. So let's look at the characteristics of an intelligent app, both from the perspective of the user and then what it means for us as developers. So for example, from a user, we want the application to feel like you're working with somebody who knows you, like you're working with a friend. It's personable, it's approachable, it understands what my behaviors are, and it can respond to them. So that's where we bring in we start talking about the ability to understand faces, be able to recognize the users, be able to understand their emotions, be able to interact with them in many different ways. Also the ability to collect data from a broad set of sources and still bring it all together and actually rationalize it and formulate a model, a view, a 360-degree view of the customer. The application needs to feel current. It needs to be up to date with what's going on in the world around me, but also with the actions that each user takes. It needs to be able to use that information, plus the information of the awareness that it has and the context that I'm in, to be able to actually make predictions about what I'm going to do next. The better that the applications can do that, the better we can predict what our users want, the better experiences we can provide them in our apps. You know, there's nothing better than an app that actually is one step ahead of you and knows where you want to go. There's nothing worse than an app that thinks it's one step ahead of you and actually tries to take you in the wrong direction. So there's a very fine line that we have to walk when we do this. And that's where real-time feeds come in and predictive models come into play in terms of how we drive the behavior of our application. And then finally, the app needs to be always available, and it always has to have the context that I'm in. So there's a lot of information that we want. I've worked on systems that have maybe 1,500 different data feeds coming into the application in the back-end system to provide a comprehensive view of the user and the world that they're in. So that requires a robust information management system that actually lets you reason about the application and about the data that you're going to use in the applications. We need to be able to then take the information that we have and project it out to n number of form factors with also n number of interaction semantics. Some people, it might be better to reach them through text. Other people, it might be better to just give them a user interface they can click on or use a touch interface. Other people, it might be better to reach them through images. And then, of course, the standard cloud qualities of the app needs to always feel snappy. And so if there are millions of users hitting it, or if there are only hundreds or tens of users hitting it, it should feel fast all the time. So it needs to be able to scale and yet still be cost effective. So scale up and scale down. So these are the characteristics that drive the app. So you might think, kind of, well, how do I deliver all of that? How do I, if I'm going to sit back and write this application, imagine that you had to start with the form over data that we had 20 years ago, and your job was to go build all of these systems. It's kind of like, where do I start? And some of these are very hard science problems. They're hard algorithmic problems, and some of them, it's not even the algorithms, it's you can't solve them unless you have mountains of data. The saying that data trumps algorithms. If you have enough data, you can do better with an okay algorithm than you can with an awesome algorithm if you've got enough data. And so for some of these problems like speech and image recognition, you can't really solve the problem well unless you have massive quantities of data. And so how do you do that? So this is really what led us to create Cortana Intelligence. Was we looked at the assets we have in Microsoft and the assets we've used over the last decade as we've built things like Bing and Xbox Live and Office 365 and our other assets. And we've built giant computing infrastructures. We've built systems that run hundreds of thousands of nodes and calculate understanding of the text and the images and the speech. And what we're talking about here is really how we bring that forward so that anybody can use that in their own applications without having to have all that data or all the algorithms or all the compute power. And that's really what led us to Cortana Intelligence. So we're going to basically go through these three sections. These are really the three, you can think of these as the three pillars that we have in the suite. There's intelligence, which is about enabling applications to feel more human. In a sense, intelligence in an application is really making the application feel closer to a human interaction. There's actionable analytics, which is how do we enable applications to make decisions to predict what our users want and then make decisions and actually change the behavior of the application based on those predictions. A common case here is when you have scarce resources, so anything where you've got inventory management, for example. And then finally, none of this is that relevant unless you have a rich data platform that you can use to operationalize all the data that's coming off of the applications, process it, combine it with the models you've got to create insights, and then feed those back into the applications. And so there's a cycle that we see happening between the applications and the data processing systems. And so you have to have a rich platform for processing the data underneath the apps. So what we're going to do now is drill into each of these, and then we'll do demos for each of these and kind of show you how you can integrate various parts from each of these pillars into your applications today. This is kind of the developer view of Cortana Intelligence Suite. Up until this week, it was called Cortana Analytics Suite. So that's one and the same. We renamed it to Intelligence really to reflect the intelligence APIs all coming in and the investment that we're making in surfacing all those APIs up to people. So we have information management services, a data factory, which does automation, it does orchestration and data movement. We have data catalog, which just went to GA this week and does information management, event hub, which does event processing or event ingestion. We have big data storage technologies, machine learning and analytics technologies, and then intelligence services. Some of these have been around for a while, so I'm not going to drill in on every one. We'll focus mostly on intelligence and then some of the information management and some of the machine learning pieces. And then, of course, we connect all that up in through Power BI and other analytical tools. All right, so let's talk about intelligence. Really, I want to talk briefly about some of the services we announced. Who here has gone to any of the sessions on the cognitive services this week? All right, that helps. So I'll just kind of quickly go through what they are in case for those who haven't seen those sessions. I've just got a couple slides on those. So the first one is these are about, when we say cognitive services, we're talking about services like vision, the ability to have your computer see the world around you, see the users, and give you feedback in the system about who are they, how old are they, what's their gender, are they happy, are they sad, how are they responding to your application. Speech. So it's not just speech recognition, but it's what if I'm trying to write an application that's processing data that comes in from people with an accent other than what my model understands? How do I compensate for that? Or what if the connection is a bad connection and so the speech that's coming in is garbled? How do I compensate for that? Language processing. A really common scenario here that we've seen between language and speech is call center analytics. So if you've got calls coming in, whether it's a help desk or a call center, and we feed those into the speech API, and that converts it to text, and then we feed that into the language API, and that does topic extraction and sentiment analysis on the topics that are in the text, then you can say, hey, last week we released a firmware update for the Surface Pro 4, and since then we've had an increase in positive sentiment on topics that are related to the Surface Pro 4. Or, hey, whenever we have calls that come into this group in our organization on this topic, people tend to be more happy talking about that topic with this group than they do when they talk with this other group about that topic. So maybe there's a training mismatch we need to go figure out. So all kinds of analytics when you start to combine these services. Knowledge lets us understand, this is tapping into the Bing graph and the entity relationships that we've figured out and calculated in processing all of the data that is in the internet. So things like if you saw the word Times Square in your application, is that talking about a place or is it talking about something else? Could the word times mean the times of day? Could it mean Times Square? Could it mean something else? And the knowledge services will actually, you can feed the sentence into the API and it will tell you what it actually means, what the word times in that context means. So it will understand the context of the words in the language in a sentence or in a paragraph and then tell you the meaning. And then, of course, access to the search APIs. We've also announced this week the bot framework. So this is an interface for connecting your bots, or for building bots and then connecting bots up with APIs. So in this case, we've done a demo in Satya's keynote of a bot that actually we built connected up to the Domino's Pizza API. So you can actually you can have a text experience with what is an API and connect the two up. So then your users, you can reach users in different ways. You can reach them on Skype, on SMS, on Slack, on Office, on Twitter, on whatever text system they might be interacting on. So that's another way to connect your application up to your end users in a way that's relevant to them. The bot framework has 3 pieces. It has the bot connector service, which will connect the bots up to the various text systems. We have the bot builder SDK, which is actually how you build your bots. And then we have the bot directory. And the bot directory is coming soon. It's how you can discover different bots and then try them out and make use of them. So with that background, I'd like to turn it over to Elad Ziklik, who is a principal program manager. He's also the man behind the What If application. So we'll turn it over to Elad, and he's going to show us some of these intelligent APIs in action.
Thanks, Lance. So, hi. My name is Elad Ziklik. I'm part of the team that built Murphy, that thing that I have on my shirt here. And last year we built the Howell.net. We try to make machine learning and now cognitive services cool and fun and useful, both for enterprises and for developers. You've seen a bunch of our kiosks lying around various places in build. This is one of those games. This is a real-time kiosk that I can look at it and it tells me sort of how old I look. It actually recognizes me and it does emotion tracking in real time. So if I smile to my camera, you'll see that it's recognizing me as smiling. I'll make my best surprise look. I'll try to be something very angry, like, yeah, I got that one good. So as you already guessed, I'm sort of the comic relief for this session. I know it's a very late evening and most of you are tired and want to go home. So I'm going to make this a bit of fun for you over the next 8 to 10 minutes. And so this is emotions. But what I'm going to show you is a little bit about what we call Murphy. And if you've seen this. So Murphy is a robot that has imagination. It can answer any kind of what-if question about the future that you would want to ask. So it can do things like, what if Miss Piggy was the Mona Lisa? Okay, which sounds like a relatively relevant question that anybody wants the answer to that one. And it produces something that looks like this. You can go and say something like, what if I was Superman? In which case you will need the camera. I'll put my best Superman look. And voila, I'm Superman. And if you didn't like this one, you can actually scroll. There's an interface that you can actually go and scroll and find some other Supermans. I think this is not good. This looks very bad. Now, let's see whether this one. Oh, I totally pulled that look. So I'm gonna stick with this. Now, what you see here is you see that little robot that picked up. This is Murphy. This is our robot, and what he does right now is actually he's looking at me through the camera to figure out whether I like this. So if I do a big smile, it's like, hey, this is wonderful. It's like going to be very excited. If I do like a very sad and angry face, it's going to hide below the thing. And this is an example of how an empathetic application is built. Okay, Lance mentioned that this is a way for app developers to start building apps that are context aware, that actually know what's going on around them, know if a user is happy when he uses them, know if a user is frustrated when he uses them. Like over the next 5 minutes, I'll show you a bit more technical on how this was built. Now, obviously, it doesn't have to be about me. It can be things like, what if Scott Guthrie was Tom Cruise? He actually pulls a mean Tom Cruise. It's almost impossible to believe that it's not him. But this is really Scott Guthrie, and let's do one more. Let's do, what if Satya Nadella was Yoda? Sounds like a good example. I'm going to take this away before people take a photo of that. And last one, we can do, what if, I don't know, Donald Trump was on, no, that's not a good one. What if I was on Baywatch? Okay, that's always a dream of many people that lived in the while back. Hope nothing bad comes out of it. I haven't tried this in a while. Oh, I do a perfect Hoff. So this thing works. You're welcome to go to projectmurphy.net and play with this. This is right now available because of various reasons that relate to some other bots that Microsoft have released. This is right now available on a limited edition inside Skype. So you can add Murphy bot into your Skype account and chat with it in like exactly the same way that I've done this. So I can do things like, what if, I don't know, Charlie Chaplin had a very long beard? And assuming it's actually live, it will come back and say, hey, I have some ideas on what this would look like. Let me click here to open this in a border thing. And you get, what if Charlie Chaplin had a very long beard? So this is live through the bot framework in Skype and on email and on chat, on like SMS and on Slack. And let's talk a bit about how this magical thing works behind the scenes. So the first thing that we need to do is actually run a language model. We actually need to analyze what is it that you are trying to express. What question are you wondering about? Okay, so what happens in the background is that one of the cognitive services that is called Luis is running in the backend. This is a very powerful machine learning technology that allows you to build your own language model. Okay, so if I go and do something like, what if Bill Gates was James Bond? As you see here on the left side, you can see here on the left side that we train the model based on several intents. So it's not a completely open, I'm like revealing you the secret, but it's not completely open-ended, but it's somewhat open-ended. And one of the things that we know how to do, for example, is swap person. Okay, so I can actually, if I identify through my language model these are two people, okay, then I can swap the first one with the second one. So if I wrote here, what if Bill Gates was James Bond? And if I write this, I might as well just show it. What if Bill Gates was James Bond? Please work nicely. Yeah, it totally pulls off that look. So if I do this thing, what my language model does is identifies Bill Gates is the source, James Bond is the intent, and swap person with a 98% confidence is what I was trying to do. And we taught it a bunch of things, and we teach it more and more things as we see more queries from the audience. I want to take the opportunity and show you what it actually looks like. So this is the actual output of the JSON call of that model when I score against it. This is what this service is called Luis, Language Understanding Intelligence Service. This is what it actually returns. So as you can see here, it says, okay, there's a 97% probability that the intent you are going for is swap person, which is, hey, very, very good. And if I go and look all the way down.
So Luis is a service that is part of the cognitive services that anybody could use today, is that right?
Yes, it is available today. You can use it. There's free trial to all those cognitive services. You can use your Azure subscription to just sign up today. Just go to microsoft.com/cognitive and start playing with this thing. And what you see on the top is like how it ranks the intent, and on the bottom is what were the entities. So Bill Gates was the source, James Bond was the target, and I can actually very easily write a piece of code that does something with it. Switch case, if intent is swap person, take source, get an image from Bing search, get an image for Bing search for the destination. There's a bunch of machine learning magic and ranker that knows how to figure out which images would work better or worse, and then mesh them together. So this is for the language model part, which is pretty nice. But then let's talk a bit about the emotion part. How do I make this robot move and change from like going this to going not angry enough? Yeah. Okay, now it's angry enough. How do I do this? So again, this is actually pretty easy. I don't need a lot of code. Let me show you the actual code. The actual code that powers this kiosk experience. So there's an emotion API, again, part of those cognitive services. They can upload a picture. I can do this on a video stream. I can do this on images. In this case, I do it on images. So I just sample images every, I think, like 300 milliseconds and run them against the service. So the lines here is about running against the backend service to detect whether there's emotions in that image. Now, sometimes I have more than one face, so I need to figure out which face I'm going to play with, and there's like a logic here that says, pick a new face, I've looked at that face a long time, blah, 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 blah. This is a piece of logic that looks at the results and figures out whether it's a positive or negative intent. Okay, so in this case, our emotion API knows how to recognize and classify 8 different emotions: happiness, anger, disgust, neutral, whatever. So in here, we take happiness and surprise as a good emotion, and we take anger and contempt and disgust and fear and sadness as bad emotions. We calculate a score, what you call an emotion offset, that basically says, how happy is that person? And then we set the expression. So if it's positive, we make Morphy happy, which means he goes up. If it's negative, we make Morphy sad. If it's neutral, just keep him where he is. Now, the fun thing about this is that these kiosks, and I will end with that, these kiosks are all deployed in many, many, many places. For example, in the Microsoft physical stores. All around the world, there's actual physical stores by Microsoft. Every circular that you see is a physical store of Microsoft. And these kiosk apps that contain Murphy and whatever are constantly feeding telemetry, against pending approval, but think of it as any other app, are constantly feeding telemetry of people that are playing with it into our Power BI dashboard. And Anand in a minute is going to go a bit deeper on how this actually works. And you can see how many people played with this. You can see where there's a lot of traffic. You can see demographics. You can see happiest location in the last 24 hours. Okay, so you can figure out where are people happy and where are people not happy. Again, this is not in the store. This is just in front of that specific kiosk like we have around here. Everything is anonymized, blah, 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 blah. And you can even do real-time things. So these are the emotional response in the last 5 minutes. Are people happy? Are people not happy? Aggregated across the various Microsoft stores. So you can see that people in Redmond are relatively happy over the last 24 hours. That's because most of the engineers are actually here, so everybody else is happy. So one last demo and one last minute. We showed you a bit about emotions. We showed you a bunch of these things. And look at what other things you can do. So you can do things like, and this will be the last one, you can do things like, think of a game that has this. And when you see this, so this is a real-time game where I need to do the emotion, various emotions. So I smile to start, which is, again, a very fun thing to do. Now I need very, very, very quickly to go through various emotions. So I need to be disgusted. How to disgust? Okay, I got angry. Contempt, as everyone said, is easy. Okay, I do this. And I want to show you the nature of how fast that thing is. Okay, even though everything is running on the cloud, there's no SDK that runs on my desktop, everything is runs on the cloud, it's super fast, super easy to use if you want to build whatever kind of crazy experiences. And as you see, I went away from the camera, so it detected that I'm gone, put back the home screen and says, hey, just smile to start, which is a new way to say hello to a computer. Thank you, guys. Bringing in Anand.
All right, thanks, Gilad. So that's pretty cool stuff. What do you think? You like that? Pretty cool, right? It's like, and that's something you can do just by calling the APIs. So it's available for everybody. So now we're going to talk about actionable analytics, and I'm going to invite Vivek Gupta up here, who's a senior data scientist on our team, and he's going to walk us through how we can use machine learning to take actions in our applications.
Thank you, Lance. All right, so today I'm going to talk about motorsports. Lots of really fast vehicles in all sorts of types of races, and where we've been working with some teams and some organizations in order to understand what we can do. You're looking for, again, as Lance mentioned earlier, low latency services. You're looking to be performant, and you're looking to augment what they currently have available as far as data goes. These organizations are run by very strict rules during the races. So for instance, in NASCAR, you have some data that's available actually during the race. You have what lap count it is, how much the lap time is taken, what flag conditions are there on the track, and what your running position is in the race. What you don't have during the race is your fuel level and engine speed. And as you can imagine, the fuel level is somewhat critical of when to take a pit stop. Is it a good time to take a pit, or are you going to lose your position? If I could go a little bit faster for a little bit longer and get a better position, I might have a better opportunity to take a pit stop. After the race, they have all this information available, but they're not allowed to use it during the race. So what do? This is where we're talking about adding intelligence to an app so that you can provide that information during the race based on machine learning models and allow the pit crew to actually communicate with the driver and tell them what to do. So what I'm going to do now is switch over and show you how something like this could be implemented. All right, so let's get this up. All right, so I have here a model that I've created, and it's a fuel prediction model. So this is Azure ML, the studio, where you can create models and be able to train it with pre-existing data and actually produce a model that can help you predict some event in the future. I take this model and I train it with the data that I have, and I actually then make a predictive experiment. So this is one that I'm actually going to turn into a web service. So as Elad showed, this is stuff that's actually running out in the cloud. You can actually deploy it, and just by deploying it as a web service, you can set this up as a web service that's available for your applications. So let's take a look at what's provided as part of the web service.
So Vivek, what if I don't have a data scientist like you to build the model for me?
Well, one of the nice things with these models is we actually provide a large number of data science, various algorithms already approved. You don't have to write in R, you don't have to write in Python and create your own algorithm or learn how those libraries work. We actually provide you some. And the nice thing is you can actually use an array of them, test them out. You do have to learn to interpret the results a little bit and determine what the right algorithm is, but you can make use of Microsoft's years of learning right there in the studio. All right, so here in the web service, what we do is we actually provide you an API key. We have a REST service that's available, give you the URL, show you how to do the headers, provide you what the inputs are for this particular service. So this is the coordination between either your developer who knows data science or your data scientist. This is your handoff. Here's how you call my web service and add intelligence to your application. And finally, we get what the response looked like. But the most handy part here is actually having sample code already available, both you have it in Python, C#, and R. So you can grab the code right from here and do it. Today, I'm actually going to use the Python version of the code because I'm going to show you another feature that's available here. So here we have notebooks. Jupyter Notebooks are a way to interactively work with your API that's available using R or Python, R which was announced this week as GA, and Python as well. And you have this ability to actually create a new notebook. And we're going to do a Python 2 notebook and do it as fuel prediction. And it opens up a blank notebook. So I have some boilerplate that I'm going to start with. And we'll start with this. We have the ability to actually access our workspace. That was where I was actually running earlier. And that connects me to the workspace and allows me to access the data I have there. And what I've already done is I've actually created a data set that I'm going to use to test out my web service and see, hey, I want to build an API for my developers to be able to call this web service. And I want to test this out here. So I now connect it up. I have data available, and it's all set there. And let's take a look. Oh, sorry, I pasted the same thing twice. Yeah, we'll just put it here. All right, I'm not doing. Apologize. You know what? Let's switch over this way. All right. So here, we'll just connect this up. We have this set up. Run that. We get back that our data set's been loaded. This is a copy of the code that was there in the web service documentation. And all it does is I've replaced here the sample data that I'm trying, and I've put in the API key. So we can now run this, and what we should get is a result. So we got a brand new result here. I now want to start building out an API for the users to use. So I've defined a method here. I've taken an input that I want to be able to substitute the input. I don't want to have a hard-coded piece of input. I want the user to be able to create data sets, be able to call this as an API, and I've replaced my data input with the input to my method. And let's run this. This defines the method now. And we, instead of returning the JSON as we were before, we extract out just the results. And if we go here, we can take a look. And so we're getting back the fuel used for each lap that we've passed in the data for. So this is a way that we've added sort of an intelligence that they didn't have during the race, but by having the time of the lap, we're able to get back what the fuel used is. Now, really, just knowing the fuel used isn't any good. We saw in that gauge, what we really want to know is how much fuel is really remaining. So I start fiddling over here with the data, and I can take a look, and I can append some things. I can say, hey, I started out with 8 gallons of fuel. What's the fuel remaining and the total fuel used? I could then take this, and now I'm sort of iterating here, and I can add it back to my API and annotate my API. So in this sort of interactive environment, I can build up my API before passing it over to a developer to use in their actual application. And then finally, we're going to take a look, and you can see sort of the results here and graph it out. One of the nice things with the Python, the notebook here is, I have this in a workspace that I can actually share with the other developers on my team. So I can provide this notebook to other developers on the team, and they can look through it, they can add to it, and we can sort of interactively work together in order to build this out before shipping it out to somebody else to use an actual API. And we're using the same web services that everyone else will end up using. I could do this in R as well. I could do this in Python tools for Visual Studio or R tools for Visual Studio, or I could go back to C#, or really, since these are web services, I could do this on any platform I wanted to and add that intelligence to the application. As Elad showed you, it can be phones, it could be Skype, it could be anywhere that you're adding that intelligence to, but it really depends on having that model that's built up out of the data.
Awesome. Thanks, Vivek.
Thank you.
So the thing I like about that is a few things. One is that Vivek showed how you can take any model and consume it in your application, and how Azure ML and Cortana Intelligence enables you to quickly operationalize the model. The other thing is the model he showed, although it was NASCAR, it was predicting fuel consumption, basically any business that has scarce resources or any kind of inventory where you want to predict how that inventory is going to be used can use models like this to build better experiences. You can actually feed that knowledge back into the application. So if you know, for example, that you're running low on a particular resource, you can send that to the application, and it might be that somebody takes an action like a driver taking a pit stop, but it might also be a user getting a recommendation for a different resource. All right, so the last part we're going to talk about today is really the trusted data platform piece, and that really is how do we stitch all of these pieces together? Like we've got intelligent models, we've got advanced analytics in the models, we've got intelligent APIs we can call. None of those really work, though, if you don't have reliable, operationalized data flows connecting them all together. And it has to be repeatable, because you want to routinely retrain your models and enhance the predictions that you're making. So now I'm going to go to Anand Subaraj, who's going to talk about basically how you pull all these pieces together and stitch them together to operationalize the model. Do you want, which one are you on? 6. Okay.
Thanks, Lance. Thanks, Elad and Vivek. That was awesome. So Elad and Vivek, what they showcased was how app developers can leverage the power of Cortana Intelligence Suite to build modern and creative applications. Today, applications cannot be separated from data and analytics. Modern developers are obsessively trying to collect data, process them, transform them, perform predictions, not just for operational insights or telemetry, but leverage the data, feedback into the app, make the app more intelligent, and improve the customer experience. And this is significant investment, requires complex infrastructure, technical choices, design patterns, and above all, expertise to build and operationalize analytics. Now, with Cortana Intelligence Suite, as Lance mentioned, we are providing an end-to-end platform that allows organizations to build such intelligent applications and also leverage the power of advanced analytics. Now, in this section of the demo, what I want to do is show a few things that highlights the trusted data platform of the Cortana Intelligence Suite. I wanted to start with showing the Power BI dashboard that Elad briefly showed. And here, what you see is the insights that you can obtain from your applications. And these are some of the interesting insights. You can know in real time how many users are using this application, what they are doing with the application. And not just that, you can also see some of the interesting trends over time. This is just a quick peek to show some of the examples of insights that you can leverage out of your application. Now I'll switch over to the deck. and talk about the architecture pattern of the analytics solution that powers this app. This is a Lambda architecture pattern where the data from the application is split into a speed layer for real-time analytics that you see on top, and at the bottom, it's the batch layer for doing batch insights. I'm not going to go over each one of these services. Lance has already covered that. But what's interesting here is that in the batch layer, we are able to operationalize a machine learning experiment similar to what Vivek showed, but not just use that for batch scoring, but also leverage that and operationalize retraining of this model on a cadence, and also update the model to make the apps more intelligent. With Cortana Intelligence Suite, you can create these Lambda architecture pattern, build and operationalize these at scale for addressing a wide variety of scenarios ranging from retail, healthcare, finance, et cetera, and use fit-for-purpose tools like the ones that you see here. What I wanted to do for the next half of this demo is focus on the batch layer. So I'm switching to Azure Data Factory. This is one of the core components of Cortana Intelligence Suite. This allows organizations to operationalize, schedule, monitor, manage batch processing pipelines. Azure Data Factory also provides a globally deployed data movement service that can be used to move data from a source to destination at scale. Now I'm going to click on this monitor and manage, and this opens this particular view, this diagram that shows the batch processing pipeline in action. What we are doing is getting the data from the application, spooling that into Azure Blob Storage, and once the data is stored in Azure Blob Storage, which is the long-time storage here, we are able to partition that data. And once the data is partitioned, we are able to run a bunch of analytics on this data. Now, we have these pipelines that are processing the data using Hive running on HD Insight clusters. Now, if I open this pipeline, I see the Hive job that's running on the HD Insight cluster. Now, this is the Hive job that is running on an HD Insight cluster, and this HD Insight cluster is created on demand. Users can provide the configurations of the cluster, and now based on the configuration, we create the cluster on demand, run this particular job, and once the job is completed, we tear down the cluster. Now, if I go back to the main diagram view, what you can see here is there are some icons that are green and some that are red. Obviously, the red means that the execution has failed. And here I want to drill down into one of the failures. I see here that some failure has happened, and I can get the log by clicking on this and opening that up. Now, I see here a Hadoop log, and it tells me that this Hive script was looking for a particular table, a folder that does not exist. Now, I can go fix this, and after I fix that, I can rerun this particular job by clicking on this button. So what I'm showcasing here is that you can look into the Hive jobs, you can rerun your execution all from this single pane of glass without context switching to any other tools. And not just that, if I want to get proactive, I can come here and click on this to create an alert. And with this alert, I can get notified whenever any failure happens. Now, one of the goals of Azure Data Factory is to make data movement super simple for diverse data sets, be it structured, unstructured, semi-structured, big or small. We want to make it super simple for users to move data to and from Azure. We recently launched an experience which we call as Copy Wizard. And you can click on this. It opens something like this, which is a wizard to simplify data movement from a source to a destination using few simple clicks. Now, in this scenario, what I want to do is copy data, reference data that I manage on premises, and I want to move that data into the cloud so that I can marry that data with the data that's coming from the application for my insights. Now, in this case, you can execute this either once or run regularly on a schedule. I'll run regularly on a schedule and leave all these options as default. Click Next. And here you see the list of all the data stores that we support in this experience today. Azure Data Factory supports about 23 different data sources. Here we have about 12. And we are incrementally adding more and more sources over time. By the end of this year, our goal is to support up to 50 different data sources. Now, in this case, I'm going to click on on-premise SQL Server. That's where my reference data is. Click Next. And provide the configurations, the connection details. And what we provide is a piece of software called Data Management Gateway for connecting to on-premises. Once you have this Data Management Gateway installed, it acts as a dedicated tunnel between on-premises and cloud and securely moves data between on-premises and cloud. Now, in this case, I already have this installed, so I'm not going to create one. But if I want to create one, I can click on this to create a gateway. Test connection at this point in time. Come on. Once the connection is tested, I can see the list of tables here. And these are my reference data. I have reference geocode dictionary and zip code. I can click on this to get a preview of this data and also look at the schema. I can select all of these. It also allows me to apply additional filters. In this case, I'm not going to do that. At this point in time, all the source configuration is completed. Now I can configure my destination. Here, in this case, I'm going to pick Azure Blob Storage because that's my long-term storage. I can also move these data to Azure Data Lake or some of the other relational stores that we support. Now, here it's going to enumerate the list of accounts in my subscription. It's going to take few seconds here. What I'm going to do here, I'll let this load and move to another experience. So what we do today is that these pipelines are producing tons of data. And there are other data sets in the organization that are super important to make it easily discoverable. We have Azure Data Catalog as part of Cortana Intelligence Suite, which allows organizations to search, discover, and reuse data sets in the organization. Now, take this example. I am a data developer, and now I want to use geocode data, which I do not know where it exists. So I can go into Azure Data Catalog, search for the data set. I can say reference geocode. I've already searched this before, so I see that there. And it lists the geocode data that is published to the catalog. And this is just a metadata catalog for the organization. So I can now look into this, get the metadata information about this particular data set, see what is the name, if there were any friendly names, descriptions, etc. Not just that, I can look into the preview. I can see the schema. And I can also look into the data profile, which provides me all the information that I need to figure whether I want to consume this data set. Now, with all this information, I know that I want to consume this data set. So I click on this to open this in the tool of my choice. So that's Azure Data Catalog. We just announced this in general availability a couple of days back. So this is a tool that allows you to do metadata management and governance across the organization. Now, going back into this experience of copy, I see here the list of the account names are here. I'm going to pick my account name that I want to use. Move forward. It provides me a browse experience. I can browse this. Go next. I can do additional file format settings. I'm going to leave all these as default. I can also get this data in a compressed format. Here, I'm not going to do that. Go next. At this point in time, my copy is all set. The configurations are done. And I can click this to deploy the pipeline that copies the data from on-premises SQL Server into Azure Blob Storage. With this, I complete my demo. Thank you.
Awesome. Thanks, Anand.
Thank you.
Who here has had to go through copying data into the cloud? Yeah, and what did you think relative to what you just saw? Is that, hopefully that's a pretty good step forward. Did this also do a bunch of things like retries and managing the semantics of moving the data around? So what we're really trying to do here is simplify that process. I was going to say, a funny thing we did with this stuff, let me switch back over to the slides, was we had an executive retreat a couple weeks ago, and we trained a model to recognize the faces of all of our executives. And then we had a kiosk that had Elad's application up, and then it was sampling every second. So we basically had a Power BI chart that showed us every executive that looked at the kiosk, how much time they spent playing with the application, and then what their reaction was, if they were happy, sad, annoyed, frustrated, or confused. So it actually was pretty cool to come back and play with it and see, I won't tell you, they got kind of, I think, out of control in terms of the queries they ran, but they were pretty funny. And I think the Baywatch this was not the first time the Baywatch query has been run, and I'll leave it at that. So I wanted to talk briefly about roadmap. So there's a lot that we covered here today, and you could imagine you could have an entire day's worth of sessions on the services that are inside the suite here or more. But just to touch on a few key things, one of the core focuses that we have with creating this suite is really taking a solution-oriented approach to the platform. And so in addition to adding the APIs like the intelligence APIs, it's really building experiences that span across multiple services, because one of the things we see as developers go out to build solutions on Azure is there are lots of choices to make between the services. And we see questions for, hey, give us guidance on what patterns to use. And so that is a big area of focus for us within the suite, is building out the patterns and building out experiences that actually guide you through the right patterns or through the patterns that we see customers having the most success with. So that's what this solution category is about. So in the next few months, you'll see a solution coming out that's lead and opportunity scoring model that's an end-to-end solution that we'll deploy. And you'll see us adding more and more solutions in this space. On the intelligence front, we just announced the cognitive services and the bot framework previews. There are a bunch more APIs that are going to be coming out in that space. There are lots of cool things that we have coming up over the next several months. But frankly, there's a ton of new services out there with this announcement. So I encourage you to go play with those. And I have a link in the next couple slides for where you can go to get those. So in the deck, there's pointers to all this stuff. In the machine learning side, there's a lot of work we have going on. There's a competition platform, which lets us run different competitions that people can actually participate and build their own models and try and answer new questions. We have one that's on inferring what people are seeing or thinking based on the brain activity that they have going on, which is an exciting model to help people who may have problems communicating or limitations that make it so that they can't communicate. This can actually enable them to communicate. And we have some really cool examples with that. We also are focused on availability in new regions like Germany, encryption and compliance, updating the various Python and R runtimes, and then adding scale and new algorithms over time. We announced this week R support for HD Insight running on Spark, so we can do models at scale on top of Spark and on top of MapReduce in HD Insight. And then coming in the H1 of next fiscal year is the GA of Azure Data Lake Analytics and Azure Data Lake Store. And then at the end, we talked already about Azure Data Catalog general availability this week, and you just saw the code-free copy preview with Anand. We're focused fairly substantially on the load to enterprise data warehouse scenario, which is an end-to-end scenario of ingesting data using batch scale-out services like HD Insight and Azure Data Lake Analytics to process and prep the data, and then land that into Azure Data Warehouse. And so you'll see more coming out on that side. And then also we get a lot of requests for data governance and lineage, and we're focused on that space as well for the data catalog. Just a couple other things. So I'll encourage you to go check out the data catalog. Try it out. It's available in GA now, and send us your feedback. There's also a whole event that we have coming up, the ISV Intelligent Application Summit. here later on, or yeah, I guess it is towards the end of April. So invite you to join us there. And then finally, so this is my email address. Don't hesitate to send me mail if you have any questions about any of the services here. I'm happy to connect you up with, if I can't answer it, I can connect you up with somebody on my team who can. We want to get your feedback. Our core goal here is to make it so that it's easier for you to build these applications in the fastest time possible and get your time to solution down and be as productive as you can with them. I invite you to go to these sites. You can learn a lot about them. We have examples of the models that we've shown here today at the gallery, CortanaIntelligence.com site. And then there's a whole set of sessions I'd invite you to go and learn more about it. With that, I'd like to thank you for coming. I'll hang out outside in the hallway after this session to answer any other questions that we have, and have a great time the rest of the event. Thanks.